Hi, Daryl. Looks like you've got a nice piece of aggregate or concrete here.
Yeah, actually, it's a piece of asphalt, Danielle. It's a customer of ours, BDI, dropped some of these asphalt samples off that are cores they took out of some of the roads up in the mountains of North Carolina. And the goal for us is to install a strain gauge on it and kind of show folks how to go about doing that. And we're going to use these, it's actually a 2-inch long pre-cabled strain gauge that we're going to glue onto the surface. And one of the things about testing materials like this, whether it's concrete or asphalt, is that a lot of times you want to get sort of an averaging across the surface. You know, if you take a look at it, you'll notice a lot of rocks and the asphalt and how all that stuff is kind of
Sure.
combined together.
In fact, it looks like a lot of these guys are about an inch in size or less.
Actually, that is an excellent point. And that's why I've got this little steel scale, and so that I could look at it and lay it up here and just kind of get an idea of how big that aggregate is.
So what is the rule of thumb that we use in this situation? Because we got a variety of different sizes of aggregate distributed throughout this piece.
That's right. So typically what I recommend to customers is to pick a strain gauge that's approximately 3 to 5 times the maximum aggregate size. And like most of this that you see is running around about a 1/2 inch or less. And in that case, the strain gauge that we're using is actually a 2-inch long active link.
That's about 4 times the size of the largest aggregate size.
Exactly,
Okay.
exactly. So what that's going to do, it's going to give us a little bit of averaging on the fact that this material is not homogeneous. So we get a little bit of averaging, and it helps to make the data more consistent from one location to the next, or also from one sample to the next. Our friends at BDI dropped off about a dozen samples. So this would allow us to get more repeatable data from one to the next, given the differences in the construction.
Shapes of the different pieces of aggregate, so you want to get a uniform average across the area, right?
Exactly. Average it. And again, typically we look for a gauge length that's about 3 to 5 times that aggregate size.
So how do you go about preparing something like this for a strain gauge? You know, that's a 2-inch long gauge, so we got to make sure that we get decent coverage and decent preparation for that coverage, right?
Right. This is it's a pretty dusty piece of material. So we put down a little bit of absorbent material as we go through the cleaning. I've got a stiff bristled brush that we're going to use. We've also got the micro measurements M-Line GC6 isopropyl alcohol. It's basically a pure form of alcohol. We've also got some Imprep neutralizer. That's an ammonia-based solution, and we'll use that for cleaning. And we're basically going to go ahead and get started. So
I noticed that you didn't have any conditioner A in this particular application.
yeah, that's a great point. Typically on these real porous materials, we get a little concerned about conditioner, which is a mild phosphoric acid, and you really kind of worry about it leaching itself out later on. So we like to use isopropyl alcohol, neutralizer, and once we finish a scrub with the neutralizer, we're going to give it a few minutes to finish air drying in case there is some of it trapped in the pores.
Okay.
Also, we're going to use these gauze pads for cleaning. A lot of times when you're using or you're installing gauges on metals, you'll use the cotton tip applicators, like they look like Q-tips,
Like Q-tips, yeah.
but they don't cover quite enough area for what we're going to do.
Sure.
And my goal this afternoon is to not so much get the gauge installed yet, but to put down a layer of epoxy to serve as a pre-coat.
Right, because of the roughness that you have on the surface here, you're trying to make sure that you can get it a little more uniform for the gauge.
Exactly. We want to make sure that we get a nice smooth surface. We're going to put some pressure on it. We've got some Tygon tubing that we're going to use. I think it's laying
Under here.
underneath the table. So basically we're going to put down a layer of epoxy, put some tape over top of it, sort of like we would if it were a strain gauge being installed, and then we'll put down a piece of silicone rubber and this little metal plate, and we'll lay that on top of it, and we'll put some pressure on that epoxy.
Okay.
And really the reason for that is so when we come in tomorrow and this epoxy's cured, we don't have to sand down so much.
Right.
You really want to be careful. You know, if you build up a real thick layer of epoxy, then you're going to be measuring the strain in the epoxy
Not
as
the
opposed.
actual part. So makes
Exactly,
sense. Makes
exactly.
sense. So I've noticed here that you're using GA2. You know, on the last time I saw something similar to this, it was concrete, and it was perhaps AE10 was used. What's the advantage of GA2 over AE10 for something that is as rough as this surface really is?
Excellent question. Mbond GA2 and AE10 are very similar. They're both two-part epoxy systems. The biggest difference is that GA2 has an added filler, so it makes it a little thicker, and it makes it better when you've got an irregular surface, a porous surface. The other nice thing about it is that it has a color to it, so you can kind of gauge how thick it is based off of how dense the color is.
Sure.
So the thinner it is, the less dense it's black, so it won't be quite as dense of a color when we squeeze it out into a thin layer. But the goal is to fill the surface and minimize how much you're elevating that epoxy up off the surface.
Okay, makes sense.
All right, so let's get started. So first step, I'm going to take a stiff bristle brush. You might want to
I'm
watch
going to
out.
back up a little bit.
And basically, you're just trying to take any free particles, stuff, dust, whatever's on the cores. These are actually in pretty good shape. These
I can
guys
see
might
it
have-
building up here on the side. A lot of that
Yeah, a lot of
debris
that
is
stuff-
coming off on the side here. Yeah.
Exactly, and it basically, you could do this all day and it'll continue to do it. You're just trying to get off any of the loose particles.
It's going to be down to the root of the surface
Yeah.
of the part.
Exactly.
Right.
So once you do that, the next step is we're gonna wipe it down, and we're gonna use the GC6 to do it. I'll just take a gauze pad, and I'm gonna saturate. I'm gonna pour some of this into the gauze pad.
So you're just applying this in a liberal manner just to make sure that
Exactly.
the area of interest is going to be properly,
Exactly. And
properly prepped for this. Yes.
exactly. Even though the gauge is relatively small, it's only a couple of inches long, I still like to prepare a good large area, because one of the things that happens sometimes when you're installing gauges is you'll drag contamination from a cleaned area, or actually from an area outside the cleaned area into the clean area, and we don't like to do that. So
Right. I've noticed that you've been wiping, lifting, coming back to the same starting point over and over just to make sure that you're not recontaminating the area, correct?
Once I kind of get started, I try to stay inside it. And really now, we're going to give this just a minute for the alcohol to sort of flash off. It's darkened a little bit, so you can tell that's the alcohol kind of doing its thing. And the gauze pad has come up with some, contamination on it. So, and in general, in doing this type of testing, you're going to have that. It's going to be dusty, and you do the best job you can with cleaning up that dust. This would not be allowable if you were trying to put a gauge on metals, but on things like this, it's pretty common.
Sure. And you just have to kind of give a minute or two for it to evaporate off the surface here and get back to that more uniform color that we're seeing outside of the area that we just prepped, right?
Exactly. So the other thing you could do to speed this up is you could take a warm air blower heat gun and blow some heat across it, and that would, you can see it now as it slowly starts to evaporate. And if you blow a heat gun, air across it from a heat gun, it would obviously evaporate a lot faster. So if you're in a hurry, get a heat gun and do that. Matter of fact, we
I
probably...
think we have one up
Do
here.
we?
Yeah.
Okay. You
I'll
wanna
just
go
take a
grab it?
walk and we'll try to speed this up a little.
Okay, all right, perfect. Excellent. I'm going to put the cap back on the alcohol because we're done with it.
Here we go.
Thank you. It's like an industrial grade hair dryer.
Is that a product of Micromeasurement, sir?
I think it is. And you can tell, already the alcohol's just about gone. You just blow a little air across it. Once you think that's pretty well gone, really the next step is normally it's to indicate some lines for where the gauge is going to be installed. In our case, I'll turn that off.
I assume this is going to be experiencing a compression load normally.
Correct.
So we're going to try to align the gauge in the long direction.
Correct. We're
Okay.
gonna we're going to position the gauge along the long axis. We're going to try to put it in about the center of the core. And we've got the silicone rubber and the little metal plate that we can use as a guide for how much of an area to cover. But this afternoon really is to get the two-part epoxy installed over top of it, get that curing so
Right.
we can wait the cure time, which is a minimum of 6 hours at room temperature.
Right.
In our case, we're going to let it go overnight, come in tomorrow, and then we'll bond the strain gauge on top of the layer of epoxy.
So after that base layer, will there be a post prep to that layer, or will we go immediately to the gauge?
Yeah, that's a great question. We still have to prep that epoxy too, so we'll
Okay.
go through much of the same process with prepping the epoxy tomorrow.
Okay.
And one of the key things we'll look for is to make sure we don't build it up too thick. If we do, basically we got to sand it
Sand it.
down.
I understand.
All right, so the next step is to scrub it with neutralizer. That's the ammonia-based solution. And what I usually do is put it on both. I'll put it into the gauze pad in this case and try to get some on the surface. This is a water-based solution, so it's going to stick around a little bit longer. And I'm just going to try to go in one motion and just try to, as I kind of work this in, try to get a clean side of the gauze down. And again, you can see it's picking up contamination. If it does, you can discard it and get another gauze pad.
So
Put a
you're
little
seeing
bit
the
more on
same
it.
kind of discoloration that you saw before with the GC6.
Exactly. Same kind of thing, and with it being water-based, it's going to hang around a little bit longer, take a little longer to evaporate. So what we're going to do is use our heat gun again. And again, I'm just kind of looking to see if there's any kind of loose particles. I just kind of want to wipe those off the best I can.
Right. You're just trying to make sure that the gauge is not sliding around on the loose particles once it's adhered, or even the adhesive system
Right.
itself, because you're not getting true strain transmission at that point. Right?
Yeah, it's amazing how a I think I just tripped the breaker. Oh,
Okay.
you have to take that out. All right, so now that we've got the breaker reset, I'm just again going to take the heat gun and just kind of
You're just encouraging it to evaporate
just
just a
trying to
little bit
hurry it
quicker.
up a little bit.
Right. Right.
Assuming we want to get a strain gauge installed this afternoon, it'd be nice to speed up that process.
I know you said strain gauge, but you meant the base coat. of
Right.
The strain
Well,
gauge,
yeah,
right?
of
the
course.
base coat.
Yeah, sorry.
Yes.
And you can tell that, sure enough, it's evaporating. And really, it's ready to go. So really, at this point, we're ready to take it, and we're going to move it just over a couple of feet here, just to kind of get out of the dusty area as we start to handle the two-part epoxy system. I kind of like to keep the surface preparation separate from the bonding on something that's this dusty. So now that any residual neutralizer looks like it's gone, go ahead and turn that off.
Let me go ahead and see if I can transport it from
Okay.
this location.
Are you strong enough? It's pretty
I
heavy.
don't know. Let's see. I think we should probably spread the feet out a little bit
Yeah,
here.
okay, let's do that. All right, so again, we're gonna install one of these strain gauges, but we're not gonna do it yet. We're gonna put down a layer of epoxy as a pre-coat, and then tomorrow morning we'll come in and we should be ready to continue the application of the gauge on it.
Do you want to mask off an area, or you feel like on a structure like this, masking off may not be as critical as it would be in other situations?
That is an excellent question. A lot of times I do, and we could in this case as well. It's one of those things where we could kind of focus that area, make it, just in case you get some epoxy that rolls out the side.
Right. You could make a dam if you wanted to
You
try to
could.
gather this.
You could. Where I normally do that is a lot of times when you're trying to control that area, because you're going to put an environmental coating over top of it.
Right.
So the wider spread your epoxy goes, the wider spread your environmental coating
Correct.
has to go as well.
Correct.
Now, all that being said, what we're going to do is just put a relatively small area of epoxy.
On top, try to keep it on the top to minimize the amount of run.
Yeah,
Okay.
and once we put a little pressure on it, we'll get a little bit of residual that flows out, but this stuff is so stiff, I think relative to that thin epoxy, I don't think a little bit of additional epoxy is going to be a problem. And we can also wipe it off while it's still
Wet.
wet and discard it.
Okay.
All right, so I'll just keep rolling here as we're going. Inside the GA2 kit, you've got instructions on how to use it. A little bit of foam in there to protect it.
I see there are 6 jars of resin in here as well.
Yep, 6 jars of resin, 1 bottle of curing agent.
Okay.
You've also got these little calibrated droppers.
Oh, the pipettes. I see.
Yep, and some plastic stirring rods. And you've also got directions on here on how to go about mixing it. These directions are for Mbond AE10, AE15, and the GA2. And as you step through, you know, it basically walks you through a step-by-step guide. You know, it talks a little bit about, at the beginning, a little bit about the properties of the epoxy and in general terms, the kind of stuff that you need to use. It talks a little bit about the cure requirements for AE10, AE15. And we get over here to GA2, which is the one we're using. And it says, you know, it's a partially filled, 100% solids. We've got a hardener with it. It's capable of 10 to 15% elongation when cured for 40 hours at 70 degrees F. Its minimum cure is 6 hours at about 75, but you can also leave it under pressure longer.
Sure.
And you get a little bit better properties out of it.
Now those strain levels are pretty high, 10 to 15%. We're looking at it, something that's more or less a brick here, you know, so we're probably not going to get anywhere close to that,
Not
you know,
on anything.
in a practical sense. So,
Right. I wouldn't expect that. Usually these things will fail at much lower strains than that. And basically it just kind of takes you through a step-by-step guide on handling the strain gauges and then putting some clamping pressure on it.
Okay.
We don't have a spring clamp big enough to clamp this thing, so we're going to use that Tygon tubing.
yeah.
I think you were bringing it in.
Sure. It has a lot of flexibility to it, so we could tie it off and know that we have a constant strain
Yeah.
or stress on this part
Yeah.
while it's curing, right?
Yeah, especially with the pre-coat, you don't have to be quite as quantitative with it, but a little bit of pressure on it, that's going to help to kind of squeeze it out, squeeze out the excess, so we don't have to do so much sanding tomorrow morning.
Sure. Now we did have a C-clamp that was big enough for this, but why did we not go with that?
That is another great question, Danielle, and the reason, personally, I don't like to use C-clamps because I think they get used a lot of times where they really shouldn't be. And when I say that, you know, one of the things you want to control when you're curing these adhesive systems is the pressure that you're applying.
It needs to be constant.
It needs to be constant. And what happens a lot of times, a C-clamp may work okay on something at room temperature, but as soon as you take it and you put it inside of an oven,
Right.
you get differential expansions of different materials, and next thing you know, it's either getting tighter or higher pressure, or it's getting loose.
Right.
So I try to avoid those altogether. Try to come up with a method where you've got a little bit of either a spring tension or like an elastomeric
Yep, I got you.
band like what we've got with the tubing.
Okay.
All right, so why don't we get started? So this is the Mbond GA2. We've got the
Curing agent that
Curing
I've got
agent.
in my hand here.
Go
Just
ahead.
trying to break the seal on that.
Yep. I'll go ahead and take out one of the plastic little droppers and the little plastic rod. If I can get it out. And the rest of it, you know, we're only going to use one mix of it right now. And the reality is when you're doing this work, you really should consider having many of these ready to go at once. Because we probably have enough epoxy here to pre-coat 10 or 15 samples.
Sure.
And you and I are only going to do one this afternoon, so it's a little bit of a waste of the epoxy.
Yes, I understand.
But in general, you'd want to at least probably have about I don't know, 10 or 15 of these ready to go.
Right.
And you just mix it up and then you start laying it down.
So I'm looking at that, and as you're moving it around, I can tell that this jar is not seeing a lot of flow out of the GA2 here.
Oh, yeah,
The
it's-
viscosity is such
Yeah,
that it's really, really thick.
Yeah, it's much thicker than what a typical epoxy would be. You know, it's hard to see probably in the camera, but if I take it and I turn it up, I mean, basically it's barely even moving.
Yeah.
So it's very viscous. So
That's actually pretty good for surfaces like this with raised aggregate sticking out off the surface. It'll help with the coating of that much better.
yeah,
Yeah.
yeah, agreed. All right, so we've got our resin, and in order to get it kicking over, we got to add some curing agent. And we've got the curing agent, and this is the type 10A, and we've got a 10 graduation on our little calibrated dropper. So we're going to use that 10 graduation to take the curing agent out. I'll take the little dropper, kind of push the air out.
And I guess one of the things you're trying to do is make sure you're reading that at the meniscus, that little dip in the fluid level, to make
Exactly.
sure that it's accurate.
I got way too much, so let me squeeze some of it back out. You bring up an excellent point, Danielle. I'm going to try to turn around here so I can see this better. Maybe one more drop back in there. And I would call that good.
Looks like the meniscus is
Yep.
right there at the 10 line.
Right there at the 10. So once I do that, I'll just touch it, take it, drop it into that center of the jar. And the curing agent is hygroscopic, meaning that it wants to absorb moisture. And these droppers, you've got enough of them, so you just take them and throw them away. Effectively now they've gotten contaminated. But just take that and throw it away. And now we're going to mix it. And we're going to mix it for 5 full minutes. So let me start my watch here.
And that's 5 contiguous minutes.
That's right. So, and when you first start to mix this epoxy, it's really, really thick, and the two really don't want to go together very well, but you just got to continue to stir it. The other thing I do, and we normally teach this in workshops, is to try to hold it by the threads of the jar.
Right, because your hand could actually add additional heat and cause it to kick over even faster. right?
Exactly, exactly. So we'll just take it and mix it.
This is usually the point where we start telling all of those great stories about gauge installations and applications and similar. Because 5 minutes is a long time. It doesn't seem like it, but it is.
It is a long time to stare at an epoxy. It's about like watching the grass grow.
That's right.
Or watching golf.
Right, right,
I could play golf, but I can't watch it.
right.
It's a little too slow. No offense.
No offense. Take it.
All right, Danielle, I think I've hit my 5 minutes.
So it looks like we have about 10 or 15 minutes before this starts to set up.
That's right. We've got to move pretty quick.
Okay, well, let me start then by just masking off the area of interest. I'm going to try
Okay.
to make sure that it's in the same plane, in the same line that the gauge is going to go. So I'll try to put these strips of paper drafting tape down.
Okay.
Based on the size of the gauge, I think about 3 inches in length should be sufficient.
Yeah, I think so. Let's make sure that maybe it's a little bit bigger. Yeah, you're basically spot on with the size with our clamping. And this is what we use to put that pressure over top of the epoxy once we get it applied. And any excess epoxy will flow out on top of the pieces of paper drafting tape, and we'll just peel them off.
Yeah, that way it looks like we thought about this a little bit before we actually started testing, you know? That's a good thing to do.
Nice little window frame there of paper drafting tape, leaving our little cleaned area here for the
String
the
gauge.
pre-coat and the strain gauge. Yep. I think it looks good. So really the next thing that we're going to do is take the epoxy. I'm going to try not to hold it in my hand like this, because again that'll decrease the amount of time I've got to use it. But I'm going to take the epoxy, and one of the things I like to do is when you first have mixed it up, take it kind of clean off the plastic stirring rod, because sometimes you have a little bit of curing agent that's kind of holding on to it. So you
And
just
it's not
kind of
really been
Yeah,
properly
yeah,
mixed. And so
exactly.
you want to make sure that you get a
Exactly.
nice mix of that. Yep.
And the other thing you want to make sure of is that you don't get it on your clothes, because if you get this epoxy on your clothes, it is not coming off. I'll just take a little drop and just kind of take it and kind of brush it around a little bit with the plastic stirring rod. And I'm just going to kind of tell it where to go.
I can actually see it falling into some of these crevices on the
Yeah.
part.
I'm going to get one
So
more
we want to
good
build
little...
it up a little bit more than that, I would assume, when we're done.
Yeah, so I'm just going to kind of... And we're going to put pressure on it. So once we put the pressure on it, that will really get this stuff squeezed out. And the idea of putting the tape, you know, is really going to help to kind of keep it nice and clean.
How thick are we trying to go with this base layer?
Honestly, it's just thick enough to create a nice uniform coat. You know, you want to minimize how much you build it up, because you could start measuring the strain in the epoxy as opposed to the strain that's in the core.
That makes sense.
All right, so the next thing I'm going to do in order to keep the epoxy off of the silicone rubber is I'm going to take a couple of pieces of this gauge installation tape, very same tape we'll use to install the strain gauge, and I'm just going to take a piece of it that's about yay long, put a little bit of tension on it just so it doesn't curl as much, and then I'll take that off, and I'm just going to kind of lay it down over the top like that. I'll take another piece.
So that just acts as an insulating layer while it's curing to make sure that the silicone rubber doesn't stick to the part.
That's
permanently.
basically it. I'm just trying to, you know, I want to minimize, you know, a lot of times you're reusing these materials, and if you start getting a lot of epoxy that gets built up on it, you know, they get kind of cruddy. So I'm just going to try to protect the silicone rubber pad. So I just put a few layers of tape over top of it. And really now we're ready to put on our layer of silicone rubber. This one happens to be a clear version. We also have a version that's kind of a reddish brick color. Typical durometer for this is about 40. And I'm going to take that, lay that over top. And we've got a custom hammered aluminum plate that's about the same radius as the piece of core, the asphalt core. I'm going to take that and lay it over top of that. And really we're at the point now where we need to put pressure on it. And there's a bunch of different ways we could do it. You know, we could, I've done it before where we wrapped it really tight with tape, and that worked. You could put weights on it if you could kind of hold this thing and keep it from rolling around.
That's going to be a little more difficult with this curvature to try to balance a weight onto that.
Right, completely agree. So rather than doing that, I think you had the idea earlier for us to use some flexible tubing, something we can kind of wrap around it.
Sure.
And maybe tie it off and pull it in a nice tension, so that's going to pull down a little bit, help to squeeze out the excess epoxy, and then we'll basically let the thing sit overnight.
Okay. So you're thinking right on top of the plate.
Yeah, so let's
So
try
we'll
to
pass this rubber tubing.
You got two. You got one piece or two?
I've got two pieces. So we'll start with the
Okay.
first piece, and
Let's try to.
I will make sure that.
Should we go around another time, you think, or
I
just
think one time is
just
good
one
enough.
time? That's what I'm thinking too. That's what I'd plan to do.
And just closer to my finger. That
Yeah,
way
that's
we get a
fine.
nice uniform clamp here.
Okay. Let's do the other one,
Okay.
and then we'll snug them up.
Again, about the same distance from the end.
Yep. Gotta make sure you eat your Wheaties before doing this. And
Want
really,
to tie them off once more just in case.
you mean run it back around?
Yeah, just tie a knot on top of a knot.
Yeah, sure.
We can do that. That way we can be pretty sure that
It's not
the
gonna move.
first one is not going to try to go anywhere or come loose. Plus we got these rovings on top of rovings, which will help this to stay in place even better.
I'm with you. I'm with you. It's got a nice tension in it. I can feel it. Let me get the epoxy out of the way. Now this epoxy has about a 15-minute pot life. So basically we've got about 15 or 20 minutes and then it's done. So we're basically going to take it, I'll just put it over here, and after about probably 30 minutes it's going to be a solid. So again, really to be most efficient with this epoxy, you'd want to have a bunch of these cores set up and ready to go. No reason you couldn't do this to
At least 6 of these,
Yes.
maybe 10.
yeah, 10, maybe more, maybe less, just depending on whether or not you got some help too.
Right, right.
But Danielle, I think we're done. So now
Okay.
it's just time to sit down and wait and watch it cure.
Sure. So I'll see you tomorrow and we'll finish this off.
All right, sounds good.
All right.
See you then.
Okay. Okay, Daryl. So this is our continuation of trying to install a strain gauge on this large composite material. But before we do that, we need to kind of make sure that the adhesive set up properly before we try to put any gauges on here. So how do we confirm that?
Yeah, that's a great point, Danielle. One of the first things to do when you get back after waiting on something to cure is take a look at the jar at which you mixed the epoxy in. This happens to be the Mbond GA2, kind of hard to read it there. But it's a 2-part epoxy that sets up in this jar in about 35-40 minutes. And you want to check it and make sure that in fact it is a solid in the jar, because if it's not a solid in the jar, you're guaranteed it's not solid underneath your strain gauges. So again, the first thing I do is take a look at it, and sure enough, you see it, it is a solid.
Yeah, you can see the mixing stem is actually in there pretty firm.
Yeah, you can't get
You
it out.
can't get it out, so
Yeah, so
I'd say it's cured pretty much in a good manner here.
now keep in mind that here it's real concentrated. So in the jar, if it's going to kick over and cure anywhere, it's going to be in the jar, because it builds up a little bit of heat and it's an exothermic reaction, so it kind of kicks over and then it helps itself kick over.
Sure.
When you spread it out in a thin layer, it's not as much, because
It actually slows down that exothermic reaction a little
exactly,
bit, right?
exactly.
Okay.
It does slow it down, so that's why we had to wait, and we chose to wait overnight. You know, we let it go. It's been nearly almost 24 hours now,
Yep.
and it's been under pressure that entire time. So first thing we do is check it. It looks good, so that tells me that there's a good chance that everything's fine here if it were a strain gauge underneath the gauge, or in this case as a pre-coat. And we'll take off the bands here in just a second so
Okay.
that we can check it. But before we do that, I do want to talk a little bit about the gauge that we're going to use. This one is one of our C2A series gauges.
That means that you're going to have some cable already pre-attached. That's about 10 feet.
Exactly. It's 10 feet of wire pre-attached to a strain gauge. The gauge grid is encapsulated, so it's got a film covering over top of it. It's made out of polyimide, so it has some flexibility to it, so putting it on a curved surface should be no problem.
I see some small whisker wires that are in there as well. Are they coated just like the gauge?
Yeah, that's a great question. It's kind of hard to see, but these are a solid copper enamel insulated wire. So even though they kind of look like they're bare copper, they're not. They're actually a urethane enamel insulated piece of wire. So no problem with them touching a conductive surface, because they've got that enamel on them.
Well, we don't really have to worry too much about that in this particular case, I would say, because this isn't really a highly conductive surface. But
Yep.
if it were, we're still safe.
Right, right. And just flipping it around to the backside, this is where you've got all the technical data, the engineering data that comes with the gauge. Down here is the part number. Again, you'll see it's a C2A. 6 means it's temperature compensated for steel, which is the most common temperature compensation we find used on concrete and things like this asphalt composite core. 20C means it's a 2-inch active length. LW means it's basically a linear pattern, and this one is a 120 ohm resistance. And all your key data for this strain gauge is found on this sticker, so the last thing you want to do is throw this thing away.
Right. I would say if you're a customer and the first thing you do is take the gauge out, the second thing should be to copy this data sheet and store it somewhere where you can get back to it.
Yeah, you could, years ago we used to talk about putting them in a file folder. Today you could just snap a picture of it with your cell phone and you got a record of it.
Sure.
It's got the resistance as well as its tolerance, its temperature coefficient, a gauge factor. Its gauge factor, you'll notice we know the gauge factor to 0.5%. That's the sensitivity of the strain gauge. This one happens to be 2.140. And again, we won't need it right now while we're installing it, but we'll need it when we connect it to the data acquisition. And then down here are the temperature coefficients. That's for this gauge from this alloy installed on 1018 steel. This is a fourth order. Actually, this is a fifth order polynomial, although there's no coefficients in for the fifth order. These would allow you to plot what the temperature response is if you were taking these gauges and putting them on steel. In our case, we're going to put it on asphalt cored samples, so the thermal output really isn't going to apply to this because we know this has much different
Thermal properties.
exactly, much different expansion properties.
And the other fact is that this test will probably be run in a laboratory condition with an MTS or Instron type machine. So these parameters would be less important, I would say.
Yeah, exactly. If it's a constant temperature, you don't have to worry about it. All right, so I'm going to lay that aside. So why don't we unwrap our present here? We'll take the bows off of it.
We'll take the bow off. All right.
I'll try to keep it from rolling. You can go ahead and kind of unravel it. And we're going to reuse these here in just a minute, these little bands. So I'll just take it and kind of lay it down. It's actually some tubing, but it seems like it works pretty well. You know, we were able to get a good tension on it, and it really pulled down on that metal plate. We'll just kind of lay them to the side. You know, here's our little shaped metal plate and a little piece of silicone rubber. And basically now, if you want to go ahead and do it, start taking the tape
So
off.
it's the clear tape that we're concerned about right now. This was what we used to kind of squeegee this GA2 into place.
That's right.
So-
We were, using that to try to, and it kept things from sticking together as well. You know, it put a little bit of pressure on it, and then, of course, the clamping pad put pressure on it as well.
I'm going to try to keep this as flat as I can as I peel it back here.
Yeah. Of course, we're going to have to sand it. So
Sure.
we're going to sand it in the area where the gauge is going to be installed. Yeah, you can go ahead and peel it all the way out. You can hand it to me. I've got a little trash bag over here.
Okay. Looks
So-
like there's a piece that decided to hang on here.
Yeah, it does that sometimes.
That's just, this is the reality of it all, right?
Take that off. You can hand it to me. I'll throw it away. Yeah, now's a good time to take a look at it. I mean, you can still see a little bit of porosity in it from the surface texture, but we're basically going to clean this first, and then we're going to sand it, and then we're going to clean it again, and then we're going to get to installing that strain gauge and epoxying it down. And in some applications, you can use the epoxy as a pre-coat and then bond the strain gauge, maybe using a cyanoacrylate adhesive.
Sure.
We've got one, what's it called again? I'm thinking,
M-Bond 200.
yeah, the M-Bond 200. So M-Bond 200 we could use to glue the gauge down
Sure.
if we were looking at a short-term application. But
Right.
here in this case, instead of doing that, we're going to use another mix of the M-Bond GA2. And again, if you were really testing samples, you'd want to prep as many of these as you could, because you don't want to waste
Right.
too much of the epoxy.
Yesterday we just did the single mix here for the single gauge that we're going to install. But obviously, if we used our time wisely, we had enough people here, we could have probably done 10 or 12 of these cores before this solidified.
Yeah, easily. All right, so the first thing we're going to do is take a little bit more of that isopropyl alcohol. I'm going to take it and pour it into a gauze pad.
And I'm noticing we're keeping the dam that is here because when we add the next layer, we're going to want to catch that as well.
Yeah, and it may, this alcohol might attack it a little bit, because that is paper drafting tape.
It may
So-
attack the mastic, you mean?
Yeah, attack the mastic to where it wants to come off, but I'm just going to kind of clean it good with the alcohol, and I think that looks pretty good. Throw that away, put the cap back on the alcohol, because again it wants to evaporate. And then what we're going to do is a little bit of abrasion. And this is a tricky part. This is where you got to use your judgment. You say, well, how much sanding is too much? Well, when you start sanding into the material, I would say that's too much. So all we want to do is try to make this epoxy nice and uniform, and take it down to where it starts to see the high spots in the material.
One of the easiest things that we could do here is look at the beige paper drafting tape that we have and look at the height of the GA2 relative to that. If it's below that, at equal or below, then we're probably good enough with our preparation. But if you were very liberal with the application, it might be thicker than that dam, so you would have to go with a little more coarse abrasive paper to break this down.
Yep. So we've got 3 different types. We've got a 220 grit, a 320 grit, and a 400 grit silicon carbide paper. Basically, this is wet and dry sandpaper. It's very similar, or not the same, as what folks use in auto body repair. This one's a 220, and I'm going to start with it, and I'm going to just take a little piece of it that's about maybe 1.5 inches long, and just take it and kind of fold it, and then just do kind of a light abrasion. And you can see it doesn't take long. It looks like you start to get back down to the surface of that.
Sure.
Get back down to the surface of that asphalt core.
And all you're really looking for is just small amounts of the aggregate material to show through, and that will let you know when it's time to stop. Is that correct?
Exactly. That's kind of what you're looking for. Is when does it start to kind of show through, and when you see that, you really kind of stop, because you don't want to start removing material. Now this would be a case where chances are there's very little risk, the fact that this thing is so large and it's asphalt based. But in general, like if you were testing composites, you got to be careful as you start to sand, because you don't want to start to break the fibers on the surface.
Right. That weakens the structure for sure.
Exactly.
Now, in this case, I can actually start to see hints of the aggregate in there. So
I'm going to stop.
We're really close.
Yeah, I'm going to stop right there, and really on something like this, probably 220 grit paper is about right in terms of what you would use to kind of roughen it, because you still want to leave some texture behind, and we want the next layer of GA2 to have something to really bite into and hang on to it. Let's let that air dry here for just a second.
It should take about a minute, maybe a little bit less.
Yeah, and you really want to see kind of a dull texture. You know, you don't want it shiny. Shiny indicates there's it's reflecting the light and there's not as much texture. Yeah, you can kind of see where maybe in a few little spots here it's starting to go through. So I would look at it and say we're about ready to put the gauge on.
Sure.
But before we do that, we've degreased it, we've abraded it. Last step, we're going to wipe it down with some neutralizer, just like we did before.
And as we said earlier, be careful. Do not use the conditioner in this particular application.
Yeah, so I'll just take it and kind of wet this, and I'm going to put some on here like so, and then I'll just kind of take it and kind of wipe it. I'll just take it and kind of try to fold it to a clean side, and then kind of do the same thing, just kind of wipe across it. And it's going to be, it's going to be wet. It's a water-based solution, so again, one of the things we could do if we want to speed up that evaporation is to find our heat gun, our little, what's it called, a Master Appliance Company heat gun, and just kind of blow a little hot air across it.
Yeah, I can see it now. Most of it is already evaporated.
Yep.
Probably 2 more passes and you should be done here.
Yep, gotcha. So really, once we do that, then we're ready to focus on the strain gauge and put the tape over top of the gauge and kind of get it ready for installation. So once I've kind of passed that over and you can see it air drying, I'll go ahead and turn that off. Move that out of the way. And then we'll focus on the gauge. So this is our, again, our C2A series gauge, 2-inch long active length. I'm going to take the shipping seal off of it. If I can get it off. There we go. Just take that. That part we're not going to need. This part is the engineering data that we will need.
Sure.
And in order to get this thing prepped and get it ready to put on the cylinder, what I'm going to do is use a piece of glass.
We
And-
probably should clean that. That's been sitting out for a little while, so some neutralizer, a couple of drops of that
Yep.
should assist.
Yep, that's a great idea. So, and the reason we use glass really is two purposes. One, it gives you a chance to have a working surface where you can lay the gauge out, but you can't use just anything. You want to use something where you can easily tell if it's dirty. So that's number one, glass. You can easily tell. You can look
Sure.
at it and
Yep.
see that, you know, there's something on it that needs to be cleaned. And secondly, it's non-porous. So when you introduce these cleaning agents, the last thing you want to have happen is it leaches into the material and comes back later
Right,
on.
and becomes a contaminant instead of a cleaning
Right,
agent.
right, because you're about to lay the gauge out right on top of it. So all you do is take the piece of glass, put a couple of drops of neutralizer on it, and then take another gauze pad and just use a couple of wipes across it. And I'm just going to do this over at the side just to try to stay out of some of the dusty area.
Oh, you mean the dusty area of the
Yeah, of the
rock?
Yep. So I think that looks pretty good. All right, so then we'll take the strain gauge and I will take the rubber band off of it. And I'll just kind of fold it.
So how do
Yeah.
you know what the right side of this strain gauge is? This is a big gauge, but I'm sure there's a polarity, if you will, or at least a right side and a wrong side for bonding. How do you know?
Yeah, so I think what you're asking me is how do I know which side goes up and which side goes down?
That's
And
correct.
That's a great question. The easy answer is to look for the shiny side. You see that side looks kind of shiny and that one looks kind of dull? Strain gauges, the backing has been treated for bondability, so it has that dullness to it to help promote adhesion. So you always want to lay a strain gauge with the dull side down and the shiny side up. Also, you look at the tabs, like in this one, it's got the leads on it and the small solder connections, and you can see those solder connections.
Sure.
So that would tell you to lay it with that facing
Faced
up.
I
Yep.
got you. I understand.
Yep. So once I get it, I'll take it and just kind of lay it over here on the piece of glass like that. Maybe if you want to help out,
I
put your
will.
finger.
I'll be your strain relief.
There you go.
Right here.
Maybe put your
okay?
finger, put it on the glass. Right there.
Okay,
You go.
I'll do that.
Perfect. Then we'll take another piece of the gauge installation tape. I usually tear a few inches of it off because sometimes it picks up a little bit of dust. And this time we probably need a 4 or 5 inch piece of tape just so that we can cover that entire strain gauge. And sometimes you're going to find the tape's going to have a tendency to want to curl. And if it does, you can either uncurl it or you can get another piece. In this case, I just uncurled it. And what I'm going to do is take it and I'm going to tack it at one side. I'm going to make it your finger. And then I'm going to lay the tape down and just kind of wipe it across the strain gauge just like that.
Are you just trying to entrap the entire gauge and wire assembly underneath the tape?
Exactly. So this is my handle. This is the way I'm going to pick the strain gauge up and move it around without ever having to touch the bonding side of the gauge.
Sure.
Because you know, you could have oils, or you do have oils in your hands, and you don't want to transfer that onto the gauge. So putting this piece of tape on it allows us to handle the strain gauge, move it around without touching the back side.
Okay.
So really at this point, we're basically ready to go ahead and transfer it off the glass. We can go ahead and position it over here on the surface, and then we'll mix our epoxy.
Okay.
So just like normal as with any other gauge install, when you start to lift the tape, try to lift it at a shallow angle like that. You have to be a little more careful since this one has the wires on it. And then you can just pick it up, and then we'll take it and we'll transfer it over here, and I'm going to try to center it right in the middle. and then I'll wipe it.
Looks pretty good. Looks about right.
Yep. You can use the tape, using the tape to make sort of like a little picture frame around the area to control the flow out of epoxy also gives you some alignment marks as well.
And with this large amount of wire, even though it's bundled up here, we probably want to assist this in some way. Do you think maybe another piece of tape across here might help?
Yeah, we certainly could. We could use a piece of tape. Let's try that. It wants to curl as well. Sometimes you just have to tell it you can't curl. I'll just tape it down into place.
Just a temporary strain relief.
Right, just helping to put a little strain relief on that wire so it's not tugging on our strain gauge. And really at this point, Danielle, we're ready to mix the epoxy. Maybe you can help me with that?
Sure.
We've got this one left over from yesterday. We'll throw that away because we don't need it.
Okay.
Our engineering data I'm going to place over here so we can keep it. We'll need it later. And then the clamp and the actually the silicone rubber pad and metal plate. We're going to use that again.
All right.
Yep.
So we've got one of our remaining jars of GA2.
Yep.
Our curing agent. We should have enough to do all these jars before we finish, so this will be
Yep.
just fine here. And we have our pipette to extract the curing agent. And a mixing stem for doing the work that we're going to need to do here. So I'm going to temporarily let the stem sit here.
Okay.
Going to expose
You can give it to me. I'll throw it away.
the resin that we have. And just like we did when we did the base coat, we're going to extract to the 10 line and then deposit directly in the center. And again, we're going to mix for a total of 5 minutes. So we talked about this a little bit yesterday, trying to hit the meniscus. There we are. You can see right there at the 10 line.
Yep, I'm with you.
So we'll again deposit directly in the center.
You can hand me that. I'll throw it
This
away.
pipette is no longer good. And we immediately go to the mix, again holding the jar directly at the top of the rim so that we don't add any additional heat that would cause this to kick over any faster than it needs to be.
Yep, so we've got 5 minutes.
And you got my clock, Daryl?
I do.
All
I
right.
just started it.
All right.
You're 15 seconds in, so you got a ways to go.
A long ways to go. And one of the things you'll notice as you mix this continuously, it starts out with a different viscosity, but as you mix over time, you'll see that it has a little more flow to it. And that's what you really want. You want that to interact very well, that curing agent, so that you get nice uniformity of the mix. Now, one of the things I've learned is if you leave the curing agent sitting in the middle of this jar and do nothing, it's going to exotherm even quicker. So you want to keep it moving. You're basically making the resin and the hardener chase one another in this jar for 5 minutes.
The other thing to keep in mind too is always try to get the cap back on the curing agent as quickly as you can because it does like to absorb moisture and you want to keep that away and that'll degrade a curing agent.
That's
So-
correct. It's hygroscopic, so we know that.
So Danielle, it looks like you're coming up to your 5-minute mark.
All right. All right. So first thing I need to do is make sure that this glass stem is cleaned, although it's a poly stem, I should say. And we always do that just because we might have some unmixed material that's still on the end of that stem.
Okay, we'll take that, throw that away.
All
right,
So
so-
we've got now a working time of about 15 to 20 minutes with this. So, and that's plenty of time for putting down one gauge. So Daryl's going to go ahead and expose the back side of the gauge.
Yeah, I'm
By-
going to lift the tape again at a shallow angle. And the other thing too, I can feel how aggressive the tape is stuck to that epoxy, and that's kind of a good indicator. There's, if it were dusty or something, you'd feel that when you pull the tape off. No signs of that at all here. All right, so now that we've got the gauge peeled back, we've got the surface exposed. Now we're going to apply epoxy to both. So Danielle's going to go ahead and take it, and preferably we try to get the epoxy from the center of the jar as much as we can. And you just kind of wipe it on the back side just like that. Yep. Nicely
Now,
done.
if aesthetics was an issue, I'd probably have a little more tape to catch, just like I dripped here a few seconds ago, just to
All
catch that, but that's okay.
We can wipe that off, no problem. And then
And then
we're gonna, yep, keep on going. We're going to put some more epoxy on the epoxy.
so our base coat now needs to have a little more epoxy so that we can have these guys come together as one.
Yep.
Glad I have my little tape there to catch that,
Yeah.
because I am.
We probably got more than we really need, but that's all right. We'll squeeze it out and we'll wipe it off. All right, nicely done. Nicely done. So now I'm going to take a gauze pad and just fold it, and I'm going to use it like a squeegee. So I'll take the tape, peel the gauge back over, and again, as long as we don't wrinkle the tape, the gauge will go right back into the same spot. So what I'm going to do is take it and just kind of wipe it down, and you can see some of the epoxy kind of flowing out the edge. And I'll wipe it down, and then I'm going to wipe it off of both sides. Give it another good wipe. Wipe up that little bit of extra that we had there. Take the gauze pad, and actually I'm going to throw that one away and get another clean one. And I just like to try to wipe it up a little bit before we put the pressure on it. But it's basically in place. So now we need to put on our clamping pressure. So this is where we're going to use the clear piece, somewhat clear. I guess you could call it translucent. That's more accurate. But
That's the silicone rubber pad from before.
yeah, and actually, as I think about it, one of the things I'm going to do before I put that on, just to make our life a little bit easier, is I'm going to put a couple more pieces of tape over top of it, just to keep the epoxy from sticking to the rubber pad. So I'm going to put a piece of tape there, and I'm going to put another piece of tape here on the other side.
We're using what we have in front of us, but we could have also just found a piece of Teflon if we wanted to do that as well.
Yep, we
As
could.
an insulating layer.
And see, this will keep the epoxy. The epoxy will stay underneath the tape, and so it'll minimize how much of it gets onto the piece of rubber. Because we're about to put a little pressure on it, and that for sure is going to squeeze some more of it out. So I'll take that, lay it over top, take this piece, lay that over top, and basically we're ready to put on our pressure.
All right, so we'll take the same two straps that we used before.
Yep. You want to give it a tug?
I'll give it a little bit of a tug here.
Okay, let's do the other one, and then we'll really tighten them up. Nicely done. All right, so let me give it a good tug. There we go. All right. And basically now we're ready to let it sit and finish curing. And literally once it goes through this cure process, again, we're looking at a minimum of 6 hours at room temperature. We're going to let it go overnight. Really the next step is to remove the
Installation tape.
installation tape, the metal plate, the rubber pad, and basically the gauge will be in place and it's essentially ready to be tested.
Maybe what we should do is stack 5 or 6 weights on top of this just to make sure the gauge is alive once we're done with this.
We could, it's going to take a lot of weight because
Yep.
once, you look at the cross-sectional area, it'd take a fair amount of force to
Sure.
generate much strain in it. But
Sure.
we could certainly try it.
We'll try it.
But at this point, we're basically back into waiting for the epoxy to cure.
All right. Good job.
All right, see you tomorrow.
Sounds good. Now that the adhesive has properly cured, we need to expose the gauge area. So first, we're going to remove the tubing that was used to act as a compressive spring to hold the backing plate as well as the silicone rubber pad in place. Now we can easily remove the backing plate and the rubber pad to expose the installed gauge, as you can see here. We still have to remove the installation tape, so we are going to do that in the same way that we always do, making sure that we peel back flat against the gauge to expose the gauge itself. And again, this is a pre-wired installation here, a C2A. So you can see now that the gauge has been bonded properly. Nice uniform coverage of the GA2 underneath the gauge. And just to clean up the area a little bit more, we can remove the outer band of paper drafting tape that we used as well. This was just a nice masking off of the area. And we can tell some of the GA2 is now adhering to the tape, so it doesn't want to give it up too easily, but that's okay. We have the gauge properly installed anyway, and this is the area that is most important. So at this point, we can either continue with a protective coating over the top of this to seal it, because it might be an outdoor test, or if this is a laboratory installation, we can leave it as is and move forward with the testing of this core. Thank you.